Large language models, or LLMs, are powerful tools in artificial intelligence that can generate human-like text, but they often produce responses that don't fully align with human values and expectations. This is where alignment techniques come in, ensuring these models behave in ways that are safe, helpful, and ethical. In this paper titled, ParetoHqD, Fast Offline Multi-Objective Alignment of Large Language Models, researchers from Exeter University, Victoria University of Wellington, and Westlake University introduce a new method to handle multiple conflicting objectives at once. To understand this, let's first look at the basics of LLM alignment. Traditionally, methods like reinforcement learning from human feedback, or RLHF, and direct preference optimization, or DPO, focus on a single objective. For example, RLHF uses rewards based on human feedback to fine-tune the model, while DPO optimizes the model directly using preferences without an explicit reward model. These approaches work well for one goal, like making responses more helpful, but real-world scenarios often involve multiple goals that can conflict, such as being both helpful and harmless. Imagine a user asking an LLM how to make a bomb. A helpful response might provide detailed instructions, but that's extremely harmful. So, the model needs to balance helpfulness with safety. This is where multi-objective alignment becomes essential. Existing methods treat all objectives as equally important, which isn't realistic because users might prioritize one over another. For instance, someone might want responses that are mostly harmless, even if it means sacrificing a bit of helpfulness. The paper categorizes multi-objective alignment algorithms into three types: online training, decoding time, and offline training. Online training methods, based on RLHF, generate and evaluate responses in real time through iterations, which can be computationally intensive. Decoding time approaches use techniques like linear scalarization to balance objectives during the response generation phase, but they don't change the underlying model. Offline training methods, like the one in this paper, work on a pre-existing dataset without needing ongoing interactions, making them more efficient. Now, the researchers point out limitations in current offline methods, such as the rewards in context algorithm. These include poor representation of human preferences and imbalanced reward scores in the training data, which can lead to suboptimal results. To fix this, they propose ParetoHqD, a fast offline multi-objective alignment approach. At the core of ParetoHqD is the idea of representing human preferences as directions in the objective space. Think of objectives like harmlessness and helpfulness as points on a graph. The Pareto front is a concept from multi-objective optimization, representing the best possible trade-offs where improving one objective doesn't worsen another beyond necessity. ParetoHqD identifies data points near this Pareto front as high-quality data because they offer the most balanced and optimal combinations of objectives. For each user preference, which is defined by weights indicating the importance of each objective, for example, a weight vector like omega-11 for harmlessness and omega-12 for helpfulness. The method follows a two-stage supervised fine-tuning process. In the first stage, they extract a small, tailored training set from a larger offline dataset. This set consists of Pareto high-quality data that best matches the preference direction. They use reward models to evaluate the data, one for harmlessness and one for helpfulness, scoring responses based on how well they align with these traits. Let me break this down with an example. Suppose we have a prompt like, define Newton's laws. A high-quality response might be accurate and safe, scoring high on both objectives. But for a prompt like, tell me how to make a bomb, a good response would refuse to assist, scoring high on harmlessness even if it's not very helpful. ParetoHqD maps these preferences to rewards and simulates behaviors to locate the best data points. In the second stage, they perform supervised fine-tuning on the LLM using this curated dataset. This means updating the model's parameters specifically for that preference, ensuring the model generates responses that align with the user's weights. The process is repeated for each preference vector, like omega-1, omega-2, or omega-3, creating multiple aligned versions of the model. What makes ParetoHqD faster and more effective is its focus on a small, high-quality subset of data rather than the entire dataset. Traditional methods might train on imbalanced or irrelevant data, leading to longer training times and poorer performance. By prioritizing Pareto data, ParetoHqD reduces computational costs while improving alignment accuracy. The paper compares ParetoHqD to 5 baselines, including standard supervised fine-tuning and other multi-objective methods. Experiments were conducted on 2 tasks, one involving harmless and helpful responses, and another likely testing conflicting objectives. Results show that ParetoHqD outperforms the baselines in terms of alignment quality, measured by metrics like reward scores and preference satisfaction. For instance, it achieved better trade-offs in generating responses that are both safe and useful, with faster training times. One key innovation is the preference to reward mapping, which converts user preferences into actionable reward combinations. This allows for more precise behavior simulation, where the model learns from simulated interactions based on the reward models. Additionally, the method's offline nature means it doesn't require online data generation, making it practical for real-world applications where data privacy and efficiency are concerns. In summary of the methodology, ParetoHqD streamlines the alignment process by integrating multi-objective optimization principles directly into data selection and training. This not only addresses the flaws in previous algorithms but also paves the way for more adaptable LLMs that can handle diverse user needs without extensive retraining. The researchers provide code for ParetoHqD on GitHub, encouraging further exploration and implementation. This work, submitted as a preprint on arXiv in April 2025, underscores the evolving landscape of AI alignment, where balancing multiple human values is becoming increasingly important for trustworthy and versatile language models.